Billions are being spent on AI systems that can process data faster than any human, identify patterns we'd never see, and execute tasks and behaviors. In our pursuit of advanced automation, we've achieved remarkable feats. Yet a critical challenge persists: the human bottleneck. These systems still need humans making decisions and governing them. This isn't a failure of AI. This is a fundamental limitation that's preventing true autonomy across industries. We have manufacturing robots that optimize processes, but supervisors coordinate between systems. We have autonomous vehicles that sense and navigate, but safety operators monitor from control centers. Here's what's really happening. We've achieved sophisticated automation, but we're nowhere near true autonomy. In virtually every complex system deployment, humans remain in the loop for governance decisions. These human dependencies create massive operational costs, personnel requirements that don't scale down with automation, response times limited to human cognitive processing, seconds instead of milliseconds, coordination complexity that grows as you add more automated systems. Human oversight requirements represent one of the largest hidden costs in automation deployments, often consuming a large portion of any expected efficiency gains. Here's the key insight. AI task automation and autonomous governance are fundamentally different challenges requiring different solutions. AI excels at pattern recognition, finding correlations in data and executing specific tasks. But governance requires something entirely different: understanding mission context, coordinating between systems, and making strategic decisions that align with human intent. Think of it this way: AI handles the what and how, but humans still provide the why, and that why is where the bottleneck lives. Research in cognitive science shows why this gap is so significant. Pattern recognition operates through statistical correlation. Strategic reasoning, what governance requires, demands causal understanding and contextual decision-making. These are architecturally different types of computation. You can't scale pattern recognition into strategic reasoning any more than you can scale a calculator into consciousness. But what if we didn't try to scale pattern recognition? What if we built systems designed specifically for governance? Systems that understand causality, process mission logic, and maintain alignment with human objectives. This approach, called causal reasoning, operates fundamentally differently from AI. Instead of correlating data patterns, it processes cause and effect relationships. Instead of statistical inference, it executes logical governance based on explicit mission understanding. When we say DADA X enables governance, we don't mean post-hoc oversight, we mean something deeper. Governance in the context of autonomous systems refers to the ability to define, enforce, and trace the rules, constraints, and policies that guide system behavior before, during, and after execution. But governance is not just about compliance or auditability. It's about ensuring that human intent remains the operative context in which all autonomous decisions unfold. DADA X makes this possible by encoding intent into causal logic, allowing policies to shape behavior directly and dynamically. It doesn't just describe compliance, it computes it. Every action is constrained in real time, and every decision is transparently linked to its underlying rules and consequences. Every action is traceable to its cause. The result is a system where autonomy remains accountable, governed not by external correction, but by embedded alignment with human-defined intents and purposes. Current AI systems built on object-oriented programming paradigms create incomplete computational sentences that require humans to serve as the subject. The system architecture looks like this. The object is the AI system that processes data, identifies patterns, and generates outputs. The verb is the automated function to analyze, classify, recommend, and optimize. But the subject is missing. The sentence requires human operators to be complete. The human remains the critical subject, the central point of control, and unfortunately, a potential single point of failure. Despite massive investments in AI and machine learning, organizations continue to experience exponential cost growth in operations, performance degradation in complex scenarios, and an inability to scale without proportional human resource increases. At Decision Zone, we've developed DADA X, an architectural breakthrough designed to address this inherent flaw. DADA X's causal reasoning engine is engineered to eliminate human governance at the operational execution layer. It creates complete computational sentences, where the system itself becomes the subject, independently evaluating mission context and coordinating autonomous responses. Organizations exploring causal reasoning approaches report significant improvements in key areas: governance decisions moving from human-limited timeframes to near instantaneous responses, coordination scaling beyond what human operators can manage, and adaptation happening in real time rather than requiring manual reconfiguration. While specific performance metrics vary by implementation, the fundamental advantage is clear: eliminating human bottlenecks in the governance layer. This paradigm shift also translates into substantial economic impact. We project significant reductions in personnel costs, training overhead, and error-related incidents. Simultaneously, it enables capacity expansion, enhances service quality, and opens doors to previously unfeasible operational scenarios, creating a distinct competitive advantage. Consider the possibilities: defense systems that coordinate multiple platforms without human intermediaries, manufacturing operations that adapt to disruptions faster than any human team could respond, transportation networks that optimize across thousands of assets simultaneously. These aren't distant possibilities. They're the natural result of solving the governance challenge that keeps humans in the loop of today's autonomous systems. Every organization deploying complex automation faces the same fundamental question: will you continue accepting human bottlenecks as an inevitable part of automated systems? Or will you explore approaches that address governance as a distinct technical challenge? The organizations that solve this challenge first will achieve operational capabilities that human-dependent systems cannot match.